Hi, my name is Brianna Smith, and today I'll be discussing how sound is transduced into action potentials. And first off, let's discuss what is an action potential. Well, an action potential is the ability to generate and propagate electrical signals down a cell membrane. The next you might ask, what parts of the brain deal with sound? Well, the section of the brain that deals with sound would be the temporal lobe. And then the parts specifically would be like the auditory cortex or the auditory association area. I know those are some of the main parts that actually deal with the sound of the brain, dealing with the sound. Okay. Let's get into the scheme and mechanism of how sound is transduced. I do apologize about the lack of visual aids. My book was the only one that I had, so I'll try to bring the picture a little bit closer so you can have like a visual of what the ear canal actually looks like. I know it might be small, but it's kind of what it looks like. All right. Sound waves travel through the air, and as they enter the ear, it hits the tympanic membrane. Hitting the tympanic membrane, those sound waves turn into mechanical vibrations. Okay. Those sound waves then travel through the ear, still passing as vibrations, transferring to the middle bones in the ear. It's three of them. The first one would be the malleus, the second one would be the incus, and the third one would be the stapes. The stapes is the most inner middle bone. Yes, okay. And the stapes is attached to the oval window membrane. And if those vibrations are passing through those first two middle bones and passing through the stapes is going to continue on to the oval window. And as those vibrations hits the oval window, that creates fluid waves within the cochlea. Those fluid waves then push on flexible membranes of the cochlear duct and bend sensory hair cells inside the duct. The ion channels of the hair cells open, and those will be your sensory receptors. Okay? They open, releasing electrical signals that alter the neurotransmitter release. All right? And this will be your chemical signal. Okay? Let's talk about a little bit what is neurotransmitter. Neurotransmitters only take place when there is a depolarization in the action potentials, right? And so the neurotransmitters are molecules that are located inside synaptic vesicles, and they can only be secreted into the synaptic cleft by the process of exocytosis, right? Okay. With the depolarization of the action potentials, the calcium voltage channels open in response to the depolarization of the action potential. Okay. The calcium ions on the extracellular fluid in the cytosol have a more like abundance on the outside of it. So once that little ion channel opens for them, they begin to flow in. And with them flowing in, they bind to regulatory proteins, initiating exocytosis, right? Okay. The membrane of the synaptic cleft fuses with the cell membrane of whatever it's trying to fuse with or bind with. And the new membrane is then aided with all sorts of proteins. Okay. The fused areas of the membrane open up, and the neurotransmitters molecules are able to flow into the synaptic cleft, right? Those molecules then diffuse across the gap, bind with the membrane receptors, and then they bind with the membrane receptors of the postsynaptic cleft. How does that tie back into sound? The sound being transitioned into sound waves. Okay. Those neurotransmitters being released onto the sensory neurons creates action potentials that sends coded information about sound to the brain. It sends coded information about sound to the brain, but it travels through the cochlear nerve. All right. the wave energy is then dissipated back into the no. I apologize. The wave energy travels across the collicular duct to the tympanic duct and then is dissipated back into the middle ear of the round window.